everybody, welcome to algebra. Today we're going to start our first day of notes, like the flipped classroom kind of notes. We're going to start units 1 and 2. I think they're going together. We'll see. Right now they are. So we'll just go with it. Excuse me, I'm still getting over a little bit of a cold. So what's going to happen is you're going to be able to watch all the video. If at any time things are going a little too fast, pause it. When I have try on your owns, which are problems that you try on your own, pause the video and work it out, and then when you're ready, go ahead and push play and we can go on to the next topic. Cool? Alright, and if you have any questions throughout the video, make sure you write them down on the sides of the notes and we will answer them next time we're in class. Okay? Alright, so we're going to make it pretty easy today. Today, we are starting units 1 and 2, which are expressions for unit 1, and unit 2 is equations. We might be merging them together. They might be one, like each separately, whatever you want to call it. Excuse me. We'll see. I haven't really figured that out yet. But today, we're going to be doing expressions. Evaluating expressions. Yay! Okay, fun stuff. Alright. First thing, we got to start out with some vocab. I know, everyone's favorite thing. Okay? Again, I'm probably going to go through this really fast, faster than you can write. Just pause me. It's your one and only chance where you can put me on pause. Okay? Alright. So a variable is a letter that represents a value. For example, x. You'll see that a lot. A coefficient is a number being multiplied with a variable. And when I say multiplied, it also could be divided. That's a topic we're going to talk about throughout the year. But coefficient would be the 3 and 3x. A constant is a number by itself. So, for example, the -7. A term is parts of the expression separated by addition signs. Okay, so here 3x and 7 are both terms. Okay, yes, and I am specific on addition signs because technically a subtraction sign is really a negative sign. So when you're subtracting, you're really adding a negative. Okay? An expression is a mathematical sentence. So these are all expressions. 3x plus 7, y, -2, those are all expressions. An equation are two expressions set equal to each other. So 4x minus 9 equals -1. Those are each 4x minus 9 is an expression, -1 is an expression. They're set equal to each other. Simplify means to perform operations to get a single value. So when we do 3 plus 5, we're simplifying it to 8. Evaluate means to substitute in a value for variables and simplify them. So when we say x plus 4, we know x is equal to 6, we can plug that in. So 6 plus 4, and we can do that math, we get 10. Okay? Alright. Sorry. I was probably really loud too. Alright. A numeric expression is an expression with only numbers. An algebraic expression is numbers and variables. So, we will be dealing with algebraic expressions. We'll do a little review on the numeric, but we'll be dealing with algebraic. I can't talk today. Alright? Remember, if I'm going too fast, pause the video. Alright, how to simplify a numeric expression. We use GEMDAS, G-E-M-D-A-S, GEMDAS. It's not PEMDAS anymore, okay? PEMDAS, P stands for parentheses. We don't use P, we use parentheses, but not just parentheses. So we change it to a G, which means grouping symbols. So it includes your parentheses, it also includes your braces, your brackets, and sometimes the absolute value symbols, the radical symbols, and the fraction bar. So we added a lot more to that. E still stands for exponents, M still stands for multiplying, and D stands for divide. Remember, that's left to right, whatever order. It could be like divide, divide, then multiply, then divide. Could be multiply, divide, divide, multiply. It's the order from left to right, so it doesn't matter which one comes first. Then A is for add, S is for subtraction, and again, that's also left to right. A lot of review stuff for you, I know. Now, here's stuff that might be a little bit newer. I think you still did it last year, but it's newer in your mind compared to PEMDAS and GEMDAS. How to evaluate an algebraic expression? Well, first, you replace each variable with a specific value. So you need to use parentheses. When you put in a new value, put it in parentheses. It's going to keep you from making a mistake when it comes to negatives especially. Use parentheses. And two, then you just go ahead and simplify and be sure you're using the order of operations. Okay? Key term is to substitute. Cool? Alright, cool. That's page 1. Alright, let's try an example. So here we have to evaluate 2ab plus 3ab when we know a is 5 and b is 3. Alright, so step 1, we're going to go ahead and plug in 5 and 3 for the a and b throughout the expression. And I will use parentheses. So it's 2, 5 is in parentheses because it replaced the a, 3 is in parentheses because it replaced the b, plus 3, and 5 in parentheses because it replaced a, 3 because it replaced b, blah, all that fun stuff. Now step 2, I can go ahead and simplify. So I'm just going to rewrite the expression because I'm starting a new step. Okay, and now there is no grouping symbols, not at all. Yeah, these parentheses, this is not a group, it's not grouping anything together, it's just holding that 3 in place. It's not a group. Like one person is not a group, sorry friends. So we're going to go ahead and look for any exponents, which we have none. Now we can go on to the multiply divide section. Now luckily all we have is multiply, so we're going to go in order from left to right. So we do the 2 times 5 first, we get 10. So I just rewrite it. Then we can go 10 times 3, gives me 30. So I rewrite it. Then I can do the 3 times 5, gives me 15. Then I can do the 15 times 3, gives me 45. Now I can go ahead and add it because I don't have any multiplying anymore. And 30 plus 45 gives me 75. That's my answer. Okay? Now it is your turn. You are going to try this one on your own. And make sure you show all your work. Do it in the space provided. I gave you a lot of space. Okay? Space provided. So you're going to pause the video basically. Pause the video, work on it. When you come back, we'll go on to the next question. Okay? We will go over these answers for these try on your owns in class. So, make sure you have them done. Okay? Pause the video. I will see you in a few minutes. Bye! Okay. So, you should have paused the video. Now I'm coming back. If you didn't pause the video, it makes no sense. Okay? So, we're going to go ahead and move on, and we'll talk about this answer next class. But here we have one where we have to evaluate. Oh, this is another try on your own. This is also a try on your own. Sorry, you should have done this one too. If you didn't do this one, pause the video. If you did, come on, we're going to go on to the next one. So if you didn't, pause now. Okay, now everyone should have it done. Okay, so that's the end of that page. That one was really easy. Come on. Miss Scully, you gotta make things harder. Absolute values. That's pretty, I mean, it's not hard, but it's better. So absolute values, remember these have these weird symbols. They're just straight lines. You got to be careful because sometimes they look like 1s. It looks like an 11 right now. It's not. It's absolute value. That's the name of it. Absolute value. The definition, an absolute value tells us the distance that number is from 0. So, for example, -4 is 4 spaces away from 0. Yes, it is below 0, but we don't care where it is, just how many spaces from 0 it is. Okay? So that's why the absolute value is always positive, because we're talking about distance, which is always positive. Okay? So here, we have another evaluating the expression. We're just plugging and chugging, aka substituting. But we have absolute values here. So here's an example where the absolute value symbols act as a grouping symbol, because it's got a group of stuff in it. Okay? So to go ahead and do this, we're going to do step 1, which is to plug stuff in. Okay, I put in the -3 for the y because there's no x's here, so it doesn't matter. Okay, so now I'm going to go ahead and evaluate. But my absolute values are as grouping symbols. I think I wrote this. Yeah, this is an example of the absolute value symbols as the grouping symbols. So we simplify the inside of the absolute value symbols first. So we're going to do GEMDAS within. Okay, so we're going to do then negative 3 times negative 3, which gives us positive 9. Now we can go ahead and add them together, which gives us 16. Now that I have a single number in the absolute value symbol, I can go ahead and take the absolute value. The absolute value of 16, well, 16 spaces away from 0, it's 16. So now that I have the absolute value symbols gone, now I can go ahead and add the 16 and the 2, which gives me 18. Cool? All right, now you're going to try these two on your own. Okay, so same thing, x equals 1/2 and y equals negative 3. So you're just going to go ahead and plug in, simplify, work it out. Okay, you're going to pause the video when you work it. And then remember, we'll have the answers when we come back to class. Okay, so go ahead and pause the video, and when you come back, we'll move on. Because we're already like 2 pages down, I think. 3 pages down. 1 more page. Then we're done. All right, I'll see you when you get back. All right, welcome back. You had fun? It was easy? Of course it was. Now we got square roots and cube roots. Well, let's go straight into it apparently. This is the radical. Okay? It's called a square root. And that's when there's no number here. You guys will eventually see numbers hanging out in this little nook. But right now, it's a square root. The explanation of it, I think this is very wordy and I don't know how right it is. What number times itself gives the radicand, which is the number under the radical. So when you take the square root, you're trying to figure out what times itself gave you that number that's hanging out under here. Okay? Here's a cube root, which looks like this. See, a number hanging out. That's the radical for it. And this is what number times itself 3 times gives that radicand, the number under the radical. Okay? Squared means that you have a number with that exponent of 2. So it's the number times itself. Cubed looks like that. It's a number times itself 3 times. Okay? Remember, you gotta pause me if I'm going too fast, because all I have to do is read. I don't have to write. So that's why we do videos. Okay, so now we're going to go ahead and fill this in. The perfect square for 1, so we're basically just doing 1 times 1 gives us 1. 2 times 2 gives us 4. 3 times 3, 9. Ooh. These are perfect squares because you're doing, you're multiplying whole numbers. I want to say whole numbers. Whole integers together, so no decimals, no fractions, to get these squares, the perfect square. Okay, and I have pictures of them in my room. I'm staring at them right now. They're very pretty. They're orange and yellow. See if you can find them when you get back. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. And for a perfect cube, you just multiply this root times itself 3 times. So 1 times 1 times 1, 1. Okay, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 125. 216. I only know up to 125, I think, by heart. I gotta think about the rest. 169. Nope. Nope. 343. And 512. 729. And 1,000. Okay? So those are the perfect squares and perfect cubes up till 10. Okay? Here's an example. So now we have a cube root in here. We're still just substituting, aka plugging and chugging. That's what I call substituting sometimes. You're just plugging it into the equation and chug it on out. So you just go ahead and plug it in. And then this is an example where it is a grouping symbol because there's a group underneath it. So we plug it in. We now have to simplify underneath the radical first to get that single number, and then we can take the cube root. So we're still doing GEMDAS inside. So first thing we're going to do is the exponents, because e comes before add. So negative 5 squared, that's negative 5 times negative 5, gives us positive 25. Now we can go ahead and add them together. Ooh, I just gave you an answer. We get the cube root of 89, which I did not plan very well because that's not a perfect square, but it's okay. You can do it in the calculator, and if you're confused, I can show you where to do it in the calculator next class. cube root of 89 is actually 4.5. Now I can go ahead and multiply it by that negative 2 hanging off the end, and we get negative 9. Okay? So here are 2 to try on your own. Remember to show all your work, because I'm going to actually ask you guys to come up and put them on the board next class. Okay? So finish these 2 up. Write down your questions if you got a little confused somewhere. I think most of this is review, but if you need any explanation on it, we can go over it in class. But yeah, that's it. And it was a 15-minute video. That's all you have. Okay? So if you have any questions, ask me in class. I will see you then in class. Bye, guys.